Today, we're diving into something people have dreamed about for, well, centuries, directly connecting our brains to devices. Just think about it. You've got these fantastical old ideas like the Nuremberg funnel literally pouring knowledge into someone's head, and then, the much darker stuff like the telescreens in Orwell's 1984, reading and writing thoughts. Wild ideas. But the core problem has always been, well, obvious, right? Our tech is mostly mechanical, electrical. The brain. It's alive, it's wet, it's dynamic. How do you even begin to bridge that gap?
Well, it turns out a really big piece of that puzzle, the sort of missing link, might be nanotechnology. We're talking about engineering things down at the nanoscale, single nanometers up to maybe a few hundred. And that scale, you see, perfectly matches the brain's own building blocks, biomolecules, parts of cells. It's the right size. So where older tech was just too clumsy, too big, nanotech offers this almost bespoke way to interface. It's a whole new ballgame.
Right, that's the key. So for this deep dive, that's our mission, unpacking how nanotechnology is making these, sci-fi dreams feel a lot more real. We'll look at medical breakthroughs, amazing research tools, and yeah, we have to talk about the ethical side too, the big questions that come up when you start talking about plugging into the brain. And what's really striking is just how much progress is happening, often kind of quietly, you know, behind the scenes. Okay, so let's get into it. How do you make an artificial device talk to something as, well, complicated as a neuron? For ages, just making contact without messing things up was a huge challenge. But now, nanotech seems to be changing the